Hello, beautiful people, and welcome back to Unit 1 of Regents Chemistry, which is Math of Chem. Today we will be talking about the last topic of this chapter, which is density. So density is basically the amount of mass in like a unit volume of any substance. Okay, so how much mass do we have in a specific volume of a substance that gives us the density of that substance. And it is specific to every substance out there. So every substance has a different type of, different value for density. You guys, and it also depends on the phase of matter. So whether if it's a solid or a liquid or a gas. So you guys are given the equation to calculate density based on its mass and volume in table T, which is on page 12 in your reference table packet. This is what that equation looks like. So density is equal to mass divided by volume. Remember the units for density. So just remember the unit for mass is grams divided by the unit for volume can either be milliliters if we are looking at a liquid, or it can be centimeters cubed if we have a solid. So the unit for density can either be grams per centimeters cubed for solids, or it can be grams per milliliter for liquids. Alrighty. So there's a way for us to rearrange the density equation, which is right here, D equals mass divided by volume. We can rearrange this to come up with the equations to find or calculate mass and calculate the volume. And trust me, Regents loves these questions. So you guys will be getting at least one of this. So make sure that you guys know these two equations. So the easiest trick that I can give you guys to kind of remember how we come up with these equations is just go ahead and let's look at the mass first. Just go ahead and do the cross multiplication here. So cross multiplication means this mass that we have on the top will be multiplying with nothing at the bottom because we don't have anything under the D. And then the density will be multiplying with the volume. So the equation that we get when we write this in simplified form, the equation that we get for mass is mass equals density divided by volume. Boom. That is the equation that you use to find a mass of something if you're given the density and if you're given the volume. Okay? Now, how can we find the volume? Well, let's start with this mass equation here. Okay? And from this mass equation, and this is the easiest way to remember this. From this mass equation, we want to solve for V. So remember how math works. When we have like one thing multiplying with the other thing, but we want to solve for that one thing. So let's say this volume is your X. You want to solve for X. So you want to get rid of the density on this side and you want to bring that to the other side of the equation. So what you can do to make that possible is just divide density on both sides of the equation. So when we do that, we can cancel out density on the right hand side, and now we just have it on the other side. So the equation for volume then becomes mass divided by density. And that's what we can use if we know the mass of something, and we can use the density to find its volume. Okay, so once again, these two equations are not given to you guys anywhere, so you will have to memorize them. Make sure they are copied down somewhere in your notes. Now, something that also happens a lot in Regents is that they give you a question where you are supposed to use the density of something to find its mass or volume, but they don't give you the actual density. They just tell you that this is the element that we're talking about, and that's because they have already given you the densities of the elements in the periodic table in table S, which is on page 10 and 11 in your reference table packet. So if you guys open up table S, you'll see that here we have a column for density for all of the elements. Okay, so this is where you come if the density for any element is not given in the question. Now remember, the density of water is approximately 1 grams per milliliter. Now, you guys might have wondered that how do some things float on the surface of water and how do some things sink at the bottom? Because of the density. So if something has a density that is larger than 1 grams per liter or per milliliter, then that thing is going to sink in the water. And if something has a density that is lower or less than 1 grams per milliliter, then that thing is going to float at the top. And this is not just the case with water. It's the case with any liquid out there. It's just that every liquid has a different density. So whatever density of that liquid is, things that have a higher density than that will sink. Things that have a lower density than that will float on the top. So just one quick thing is that when you guys are doing your volume calculations, sometimes what happens is that they give you, we are talking about a liquid, but they give you the volume in centimeters cubed. So do not worry about that because the conversion factor is that 1 centimeters cubed is equal to 1 milliliter. So let's say you are given, the question is talking about a liquid, but the volume given to you is 0.75 centimeters cubed. Well, that 0.75 centimeters cubed is going to be equal to 0.75 milliliters. So all you have to do is just change the units. Okay, and that's why you want to make sure that you're using the correct unit, depending on whether we are looking at a solid or a liquid. So what does the density tell us about matter? Well, as we all know, there are three different stages or three different phases of matter. We've got solids, we have liquids, and we have gases. Now, the basic difference between these three states of matter is how their particles are arranged. So as you can see in this picture, solids are very organized. Their particles are very, very close together to each other. Liquids, not so much. And then gases, not at all. So the more particles any substance has, the more dense it is. Just like the solids. Solids are very dense because they have a lot of particles packed together. Gases, on the other hand, do not have a lot of particles and they are like all split in different places, very, very far apart from each other, which is why liquids are less dense compared to solids and liquids. Okay, liquids are kind of in the middle. So let's quickly look at some of the calculations that we can perform to calculate density, mass, volume, and that good stuff. So the first question is saying calculate the density of mercury if 1 gram occupies a volume of that. So we are given the mass and we are given the volume. We have to calculate the density. We know the equation D equals mass divided by volume. We just go ahead and plug in the numbers. The mass is 1 grams divided by 7.36 centimeters cubed. We do our math and we get our answer. Now, one thing that we do want to make sure here for the density problems, all of them, is we have the correct number of sig figs in our answer. So remember, we said that whenever we are multiplying or dividing two numbers, whatever least number of sig figs we have out of those two numbers, that's how many sig figs we want our answer to have. So if you look at the number at the top here, it has 3 sig figs because remember decimal is present. We start from the Pacific side. 1 is the first sig fig and then 0 and 0 are also sig figs. Same thing with 7.36. We've got 3 sig figs. So that's how many sig figs we want in our answer, which means we'll keep the 1, 3, and 5, and we want to get rid of the 9. So to do that, 9 is larger than 5, so we'll just round the previous 5, and that gives us 0.136 grams per centimeters cubed. Next up, this question is asking for the volume when we are given the mass, and we are given the density. So we know the equation to find the volume of something, mass divided by density. We can go ahead and plug in the numbers. The mass is 65 grams. The density is 0.791 grams per milliliter. That gives us this answer. Once again, we want to make sure we have the correct number of sig figs. The number at the top has 3 sig figs. The number at the bottom also has 3 sig figs. So we want our answer to have 3 sig figs as well, which means we want to keep the 4, the 7, and the 8, and we want to get rid of the 2 and the 9. So the answer will be 478 milliliters. Next up, we have to find the mass of a gram of a cube of gold if the length of the cube is 2 centimeters. Now here, they're asking for the mass, and all the information that they have provided us is just the length of this cube. So to find the mass, we know the equation for the mass, right? We need the density and we need the volume. So how do we find that? Let's first talk about the density. We all know we are given the element. We are looking at gold. So we know that we can go to table S and we can look at gold and find its density. So here's the information for gold from table S. And right there we have our density, 19.3 grams per centimeters cubed. Next up, we have to find the volume. Remember, volume is length times width times height. And in case of a cube, the length, width, and height are all the same. So if they are given us the length, that is exactly how much height and width we have. So we can just go ahead and do 2 centimeters times 2 centimeters times 2 centimeters. That gives us 8 centimeters cubed as our volume. So now we have the density and we have the volume. We can just go ahead and plug that into the equation, do the math, and this is the answer that we get. Now the last thing here is we want to make sure we have the correct number of sig figs. In the first number, 19.3, we've got 3 sig figs. In the second number, 8.00, once again, we've got 3 sig figs. That's exactly how many sig figs we want in our answer. So we'll keep the 1, we'll keep the 5, we'll keep the 4, and we can get rid of the 0.4. So the answer will be 154 grams. Now this is the last question, but this is the type of question that we do get a lot in Regents. So I kind of wanted to go over this one with you guys as well. So what you have to do here is calculate the density of this sample. What you are given is the mass of the sample, and then you are given two different volumes. You have a volume of water and sample, and you have a volume of water only. None of the two volumes is for the sample, but that's what we need. So think about it this way. You are given the total volume, which is, let's say, $10 that you have, and you are given the volume of the water only, which is, let's say, $5 that you have spent already. And the question is asking, how many do you have left? Because that's what we'll be using now. So what do you do in that case? You just do $10 minus $5 to get your $5. That's what you'll be using. That's exactly what we do here. We take our total volume, which is 21.5 milliliters, and we subtract 20.0 milliliters, and that gives us 1.5 milliliters, which is the volume of our sample. So now that we have the mass and the volume, we can go ahead and plug that into the density equation. Mass is 10.23 grams, volume is 1.5 milliliters. Do the math. This is the answer that we get. We want to make sure that we have the correct number of sig figs. The number at the top has 4 sig figs, and the number at the bottom has 2 sig figs. Remember, our answer should have the least number, so that means we want to have 2 sig figs in our answer. So we'll keep the 6, we'll keep the 8, and we'll get rid of the 2. So because 2 is less than 5, we don't need to round the 8. So the final answer will be 6.8 grams per milliliter. And that, my beautiful people, is the end of this chapter. So I am going to peace out with that. I hope you guys learned something from this, and I'll see you in the next one. Happy learning.